Chase one, do you read me, Ed?
Go ahead, Chief. Bandit is not in view. He sure can move that thing. You have his track?
I've got him, but it's gonna take a while to catch him. You're only 10 kilometers per hour faster. He's on vector course 090 degrees at 340 kilometers per hour. Your vector is 080, and I read you at 350 kph. You're closing in, Chase One. Bandit is 2.5 kilometers diagonally ahead on your left. You're 15 minutes to intercept.
He's out there somewhere, Ed. Isn't there a lake up ahead, Charlie? I don't know. What do you say, Chief?
Hang on, I'll check. You're right, Ed. You'll have to turn or take a bath. The lake is dead ahead about 25 kilometers. Hang on, Charlie. I'll give you a new vector. Okay, Charlie. Change vector to 100 degrees at max. Bandit will turn soon.
Vector change to 100 degrees at max speed 350.
All right, he just turned. You should pick him up any second.
Stay on him, Charlie. We're gaining. We got him. We got him.
You okay, Charlie? Ed?
Yeah, fine. Those vectors really work, don't they, Chief?
This is how we draw a vector. The first thing we instinctively recognize about a vector is that it has direction. Those who lack this instinct find that learning vector direction can be a very painful experience. The second thing a vector must have is magnitude. By itself, magnitude represents such quantities as length, height, volume, mass, time, speed, or distance. And not knowing about magnitude can really put a damper on things. Magnitude and direction together make up a vector. For example, speed is 340 kilometers per hour. But the magnitude, speed, together with direction, gives us a vector called velocity. In this case, velocity is 340 kilometers per hour east. When you pay attention to direction, you can make a splash without getting wet. Magnitude quantities like length, height, and speed by themselves are called scalars. So are temperature, surface area, depth, and number. Even the number of hammerhead sharks. When a line representing a scalar, like distance, is given a direction, it becomes a vector. Vectors are also called directed line segments. The term directed line segment is used when talking about the arrows drawn to represent vectors. Drawn to the same scale, the lengths of directed line segments can be accurately measured and compared. Although the two directed line segments on the left have the same direction, they are different because their lengths differ. These two are both 8 meters, but have different directions. Simple methods of describing vectors are used. This vector can be called A. A small arrow over the lowercase a shows that A is a vector. While a vector can have any direction, the small arrow over its name always points to the right. However, knowing the real direction of a vector is important. Not knowing the vector's direction can plunge you into oblivion. All vectors have a beginning and an end. The beginning is called the initial point, and the end is called the terminal point. And these 2 points provide another way of naming vectors. This is vector AB. The initial point is always written first, followed by the terminal point, which explains why the small arrow points to the right. In this example, D is the initial point, and A is the terminal point. The direction of the vector is from D to A, so D is written first. So, there are 2 ways of naming vectors, AB and A. Sometimes we may only want to refer to a vector's magnitude. Vector A has a magnitude of 9 meters. 2 vertical lines on either side of the A mean the magnitude of vector A. Using the initial and terminal points, the vector's magnitude is described this way. Understanding vectors will keep you on the right track. Otherwise, you may go off the deep end.
Hey, Roger, I wonder what happened to Ed and Charlie.
Chase 2, change vector to 135 degrees at max.
Roger. Say, Roger, what's he mean, a vector? I don't know. I didn't even know we had a vector. Vector? I guess he did mean something. Hey, Roger, can you swim?
When it comes to vectors, Victor and Roger are all wet. Let's see what Chase 2 should have done. They spotted the bandit here at point A. They followed until the chief told them to change vector to 135 degrees at maximum speed. Had they understood, they would have caught the bandit at point C. So their route should have followed 2 vectors, vector AB and vector BC. Had they known which way the bandit was heading, they could have gone directly from point A to point C with plenty of time to spare. The new vector AC is the result of adding vector AB to vector BC. In fact, vector AC is called the resultant of vectors AB and BC.
Does that mean if we swim along the resultant, we'll get to shore faster? Roger.